Hypothesis test for a population mean. Examples. Sigma is unknown. In this video, let me explain how to find the p-values when sigma is unknown. Find the approximate p-value given the following situations. First one, null and alternative hypotheses are given. Test T naught and N are also given. What is the T naught? T naught is the test statistic. How do we find the test statistic if we had informations? It is x bar minus mu over s over root n. So you know this test statistic has the t distribution with n minus 1 degrees of freedom. So let me find the degrees of freedom first. It is 41 minus 1 equal 40. So once we know the degrees of freedom, we need to consider the t curve. Then you know p-value is the area under the curve and at the right to the 0.851 because this is a right tail. How do you know right tail? HA mu greater than 103. How do we find this area? So let me take t table. Yes. Now go to the degrees of freedom. It is here 40. Once we have degrees of freedom, we should go back to the test statistic. It is 0.851. Then we should search this row to find the 0.851. Can you find the 0.851 in this row? Yes, you see that this is 0.851. Then go back to the alternative hypothesis. It is mu greater than 103. That means it is one-sided. You know it is right tail and one-sided. So go to the one-sided one here. You see that it is one-sided. Now we consider the point at the intersection. It is 0.20. Therefore, p-value is, for this case, 0.20. That is the area under the curve and right to the 0.851. Next one is left tail. You see alternative hypothesis mu less than 18. So test statistic is 2.172 and n equal 25. As I explained before, first thing we should know the degrees of freedom. Here degrees of freedom is 24. Then let me consider the t curve. Then you know alternative hypothesis is mu less than 18. Therefore this is left tail. Therefore we find the area under the curve and to the left to the 2.172. So how do we find this one? Go to the table and go to degrees of freedom, which is 24 here. Once we have degrees of freedom, we should go back to the test statistic. It is 2.172. Then we should consider this line or this row to check the number 2.172. Do we have 2.172? Yes, we do have 2.172. Now again go back to the alternative hypothesis to check it is one-sided or two-sided or one-sided. Therefore go to the one-sided p-value and consider the point at the intersection. It is 0.02. Therefore p-value for this problem is 0.02. Third one. Here also we have left tail and t naught equal negative number. So negative 3.232. n sample size equals 61. Again, let me find the degrees of freedom. It is 60. Then how do we find the negative 3.232 in the table? But you know how to find the p-value for this. P-value probability t less than or equal negative 3.232. Why? This is left tail. So we find the area under the curve and left to the negative 3.232. But you know this is symmetry. Therefore, we can use this symmetry and we can use the positive value because we don't have negative numbers in the t table. So we have here, once we have t table, what is the first thing? Go to find the degrees of freedom. It is 60 here. Then we search that line or that row to check this test statistic. What is the test statistic? T naught equal negative 3.232, but we check the positive number here. So can you find the positive number here? 3.232. Yes, we do have 3.232. Then go back to the alternative hypothesis. It is one-sided test. Why? It is mu less than 3. So go to the one-sided p-value. Then how do we find the number? Number at the intersection. It is here 0.001. Therefore, we can say p-value for this problem is 0.001. Fourth one, we have two-sided test. So here you know T naught, it is the test statistic 2.492, n sample size is 25. Then how do we find the p-value? First we need degrees of freedom, it is 24 here. Then we should consider the t curve and how do we find the p-value for the two-tailed test? So that is this probability, it means p-value equal 2 times probability t greater than or equal absolute value 2.492. What is the meaning of this? It is the area under the curve and left to the negative 2.492 plus area under the curve and right to the 2.492. The summation of these two areas. First, go to the t table and find the degrees of freedom 24. Once we have degrees of freedom and go back to the t naught, our test statistic is 2.492. Can we see 2.492 in this row? Yes, we do have, it is here 2.492. Now go back to the HA. What is the HA? It is two-tailed. Why? Mu not equal. Therefore, two-tailed. Now go to the two-sided P. So this is the two-sided P. Then check the point at the intersection. So it is 0.02. Therefore, P value is 0.02. The last one, it is also two-sided test. But here we have x bar s n. To find the p-value, we need to find the t naught test statistic. How do we find the test statistic? You know it is x bar minus mu naught s over root 10. So we know all the information. So we can calculate it. It is 1.435. Once we have that, find the degrees of freedom. It is 24. Then what is the alternative hypothesis? It is mu not equal 66.5, which is two-sided test. So how do we find the p-value? P-value 2 times probability t greater than equal absolute value 1.435. So p-value is the area under the curve and left to the negative 1.435 and right to the positive 1.435. So let me take a t table and go to the degrees of freedom 24. So degrees of freedom 24, then what do we need? We should check this line to see the number 1.435 because 1.435 is the test statistic. Can you see 1.435? We don't see here 1.435. So what should we do then? We know 1.435 should be in between 1.318 and 1.711. Right? Again, 1.435 in between somewhere between 1.318 and 1.711. Now go back to the again alternative hypothesis. It is two-sided. Now consider the two-sided p-value. Once we have this, go to the both lines. You see that two-sided p-value corresponding to 1.318 and two-sided p-value corresponding to 1.711. So these two values, p-values are zero point 0.1 to 0.2. So p-value corresponding to 1.435 should be in between these two numbers. Again, p-value corresponding to 1.435 should be in between these two p-values. Therefore, we can say p-value corresponding to 1.435 is in between zero point 0.1 to 0.2. In this case, we cannot find the exact p-value, but we can find the range for the p-value. In my next video, I am going to explain more examples. Thank you.